Hey folks, this is me, Vishwas Nair. I'm the host of this podcast. A lot of times I've realized one thing, you know what? Debuggability in your entire troubleshooting steps in the Kubernetes environment is getting tough over a course of time. I think there is a lot of engineering solutions that are coming up, but I feel that there should be an organized approach for it. I feel Commodore as a company is doing its own approach in order to get that right engineering aspects into that step and making sure that we as engineers sleep very early, get up every morning, thinking that, okay, there is somebody to troubleshoot with me. And thanks to UD for being on my show means a lot because Commodore as a community, it's not community, it's KOMMUNITY, community, by the way. So they're pretty much building an entire ecosystem for the developers to come enjoy the way which they started debugging and troubleshooting the Kubernetes. And I think thank you so much, Yuri, for being on my show. It's a lot.
Sure. Thanks for having me, Russ, and I'm glad to be here. I'm Udi. I'm a developer at Commodore. It's like you said, it's a troubleshooting and reliability platform for Kubernetes. And today we're going to cover a bit of the challenges and why we even need a tool like Commodore, and then we'll dive deeper into how Commodore is helping developers, SREs, DevOps have a better life with Kubernetes. It's kind of like with the coronavirus, there's no avoiding Kubernetes. You just have to learn to live with it. So Commodore is a tool that helps engineers live with Kubernetes and live a better life with Kubernetes, not just solving issues, but doing so efficiently and getting better sleep, definitely.
Sure. So let's just address this question. Why do developers go so gaga about the technology called as Kubernetes? And the fact that Kubernetes is a go-to scalability solution today is fascinating. So why is Kubernetes the go-to solution for the scalability in the world today?
Well, I think there's you can't ignore the hype element. So obviously, when there's a new technology and there's a lot of talk about it, so people are excited and they want to learn and be on top of the new technologies. So that's one part. But Kubernetes wasn't the only orchestration tool. So I think the reason why it's the go-to tool now is because it made it seem like it's the easiest way to deploy, to scale up. It's not as heavy as like containers are not as heavy as a VM. It's not as time and resource consuming as having multiple VMs, and it's automatic. Supposedly, everything you have your pod, autoscaler, you have supposedly everything's supposed to happen automatically. You need more resources. Kubernetes takes care of that. Unlike the old days where you had like the bare metal servers and you had to have physical computers, physical machines whenever you needed to scale up. And here with a click of a button, it happens almost automatically, and you can adjust to your needs. And it's also very agile. It fits very well with the rise of DevOps and the DevOps methodology because it allows for continuous changes. It allows because the system is distributed, so you can have thousands of changes every day. You don't need to wait for like this big release. And I think another factor was the community behind Kubernetes. Kubernetes is backed by Google and has a huge community of people contributing and opening issues, and you have the different interest groups for every topic. So I think all those things combined make Kubernetes the go-to platform for orchestration. And now it's undeniable. Maybe a couple of years ago, you could still debate whether Kubernetes is the go-to or serverless should be the way to go. But now I think it's pretty obvious that Kubernetes is ubiquitous. It's the next operating source for its operating system for modern applications.
Sure, there are a lot of moving parts inside Kubernetes, right? No, but chaos is something that defines the truly unimaginable chaos that you can really enter in the Kubernetes environment is without understanding the basics of the Kubernetes infrastructure, because it's still Linux, Unix, backed behind, backed by its own technology. That's what it's all about. But what should be the basic and the fundamental understanding that is required in order to troubleshoot Kubernetes? And how can tools like Commodore also help us?
So if you've ever seen that picture of the iceberg, that's like a metaphor for the knowledge required for Kubernetes. So you can see that at the top you have like the very basic things you need to know, and I think this is a good place to start. Like, what is even a pod? What is a cluster? What is a replica set? You know, the basic components of Kubernetes. I think this is important to start. If you want to be at a higher level, it's better to learn like the infrastructure, you know, Linux commands, to learn how learn the history of infrastructure. Everything is so abstract nowadays. For most people, they're so removed from the infrastructure because everything is code now, and only people who are old enough or fortunate enough to have worked with like bare metal databases back then, they have this kind of holistic view because they understand the representation of the abstraction. So so I think like the very basic thing for anyone who wants to get started with Kubernetes troubleshooting is learn the basics. Replica sets, what is a Kubernetes service, then dive a bit deeper into stateful sets, networking, IP, storage, then a bit deeper into databases, queues. So I think that the right approach is to go gradually, get the basics, work on it, train it in a safe environment. Don't go straight to production. Try it on a local cluster. Maybe then move up to a staging environment. Always get the next level of knowledge, the next tier, and then test yourself. Try it. I think it's also important to do drills, to do game days, or chaos engineering basically means break things on purpose to see how you can fix them in real time when this happens. So that's a very important thing also to do, to train for things. You have tools like Gremlin, which is almost synonymous with chaos engineering. But also, I think the most important thing for anyone, for a developer working with Kubernetes, is understanding the big picture, because troubleshooting is something that you can't just do when something breaks. Things will break. This you can be confident that things will break, because Kubernetes allows you to move fast, like we said, and when you move fast, you have to, inevitably you break things. But you need to think about not just troubleshooting, think about reliability in general, because you have to prepare for that day when something breaks. You don't just get an alert and then, okay, let's start troubleshooting. No, you have to have everything in place, both your knowledge, your tools, your pipelines, everything has to be in place so that when something breaks, you can quickly fix it and not just start thinking from square one. So don't think about the narrow part of debugging or troubleshooting. Think wider in reliability. So this means preventive methods before anything even breaks. Make sure you are following best practices, that you've read the documentation, and that you're that you have everything in place. before something even happens. For example, liveness probes are always an issue. People, developers that are new with Kubernetes don't always know or remember that they should have liveness and readiness probe already. So one of the ways Commodore is helping developers with troubleshooting or with reliability is enforcing best practices, enforcing all those things that need to be set up, like request limits, CPU limits, liveness probes, and then it notifies you, hey, you have all those things in check, but you forgot to do ABC, for example, and then you prevent at least all of those problems from happening. The second part is having visibility, observability. You need to know what's going on. You need to understand we talked about all those moving pieces, and it's pretty cool with Kubernetes. You can just write a simple YAML file and you have your app. You can spin up a new cluster in no time. Everything seems super easy, but that's also part of the problem, because with so many changes, so many things happening all at once, especially if you're in a big team with many people. So you need to keep track of everything that's happening, which means auditing. It means having the right visibility tools. I'm not saying which ones, you have a lot of them. A lot of them are open source as well, but you do need to have that pillar in place so that when something happens, you at the very least have an idea of where this is coming from. Something that we see a lot with our customers is that they waste hours, sometimes literally hours, just figuring out who's to blame. Like, where is this an infra issue? Is this related to a code change that happened recently? They don't even know where to look. So a lot of the time is being wasted on just excluding things. Okay, this is not this, it's not this, this is not this, and then aha, this is where I need to look, and then spend a few more hours debugging it. So so you need to shorten those response times. So when you know where to look, so at least you don't waste all that time looking everywhere and having to wake up everyone in the middle of the night. So you can zero, if you have all the right visibility tools, you can zero in on exactly where the problem is coming from and start looking at that. So this is another thing that Commodore helps you with, because it brings all the relevant information from Kubernetes, from all the third party apps, your monitoring tools, your alerting tools. Everything is unified in one place on a single timeline that's very coherent. You can see, okay, I started having availability issues in my Kubernetes service starting here. Let's see what happened just before that, and then you can see all the changes beforehand. So I think this is the key part, tracking all those changes, because not every change is even audited. Some changes are gone forever and you wouldn't know that they even happened. So this is a use case for using RBAC in Kubernetes, but then there's also the dilemma of how much access you want to give. You give too much access, you open yourself up for more things breaking and more unexpected changes. You limit it too much, you have to do everything yourself, because developers don't have access and they don't get enough experience to do it, even if they do. So so this is another part. Commodore is giving developers access through Commodore, so they don't have to touch the cluster, the pods directly. They can get logs, they can get everything directly from Commodore. And the main benefit is just the context, getting all the context together in one place. And this is useful for the senior people in the organization and for the junior developers that have less knowledge. And actually using Commodore is teaching you Kubernetes better, because everything, and we'll get to that when we show the demo, but everything is explained. Everything is like, this is the check we run. This is why we did it. This is what we checked for. And everything is explained and easy to understand. And so as developers are using Commodore more, they also learn about Kubernetes, and it makes them better developers in the process. So I think I went on a tangent here. I hope I didn't lose you.
No, it's not a tangent, because it's also about accessibility. Because trust me, once there is an accessibility in the entire workspace that we are going to, I think what Commodore offers is fine. But yeah, let's go on with it now. Like we have to talk about troubleshooting is taken care today, because a lot of things have gone off the way. Like people say, you know what, YAMLs are helping me in one or the other way, but guess what? YAMLs are more vulnerable than what we ever had, what we ever witnessed back then, because you don't know that's a YAML file. Anything can happen there. You can just still push a container inside it without your organization minded. And of course, validating it, everything is a chaos today. So what is troubleshooting in Kubernetes, and how is it taken care today?
So I'll just touch on the security, just because you brought it up. That's also very correct. Security is also a part of reliability. It's a field unto itself, and there are people who are experts just in security. But now that every developer is deploying to production, or can deploy to production, and there's a lot of room for error there, same way we talked about introducing like reliability issues. Same thing goes with security. If the developer doesn't understand the best practices, if he doesn't use the right tooling, for example, we use Trivi by Aqua at Commodore, and we also use Polaris by Fairwinds to enforce best practices. Both are open source tools, so feel free to check them out. And basically, every developer can introduce a vulnerability if he doesn't scan his image or her images and leave, like if they don't configure the right port or whatever. So many different things can become a security issue for the entire organization. So this is also a very big part of reliability, and something that developers need to understand more nowadays, since with all the shift left movement, developers need to learn more and more subjects, and they can't just focus on writing code like they would love to. So to get back to your question, so what are the issues with troubleshooting Kubernetes today? I think the main issue is the amount of changes. I think this is like the crux of the matter. Tracking all those changes, auditing, first of all, knowing about them is not a given. And then when you know about them, you need to understand them in the right context. So you have many different observability tools you can use, but you have to have the context, and it's not easy for developers or people who are new with Kubernetes to understand it. There are very few people in every organization that actually understand it very deeply. So to get so like I said, the first thing is to understand those changes, have visibility into all those changes, and second thing is having another contextual layer of what it actually means to you. What is this good? Is this bad? Sometimes a lot of the monitoring tools we use today, like Datadog, they're great, but they don't give you any context. And if you're a developer who's seeing like a CPU spike somewhere and you think this matters or it has some effect, you will waste hours looking into it. And this is another thing that's helpful about Commodore, is that it gives you context, not just the change, but how this change affected other services, how it affects the infrastructure, perhaps. So those two things, I think, are the main important: change intelligence and context when troubleshooting. I mean,
I wasn't. Sorry for that. So yeah, next let's just go on to the perspective, or else like in terms of the accessibility perspectives, because there's a huge amount of change which is coming up in the market with respect to understanding in order to troubleshoot the clusters, the services, and things like that. So I wanted to know in a short summary kind of thing. Plus, if we can do a demo, that would be fine. So how is Commodore giving that information, giving that velocity in order to troubleshoot as quick as possible, as well as how are they effective in the production today? Like any use cases that you can show or talk, that would be awesome.
Yeah, so I think I'll jump into the platform in a minute. So
Sure, not a problem.
so you could see what I'm talking about. But just in a quick summary, can you repeat your question real quick?
How
How
can
is
tools like Commodore actually help in bringing that velocity as well as troubleshootable aspects into an ease? Because more of it is what should we understand in order to troubleshoot Kubernetes cluster from the cloud service provider as well? Because DevOps is always about velocity. We came to cloud. So now what? We have having Kubernetes cluster there. So how is it all about having accessibility and velocity in our mind when we are debugging the solution?
Yeah, so I think, like I mentioned previously, the shift left movement means that developers are in charge of more things. They have to own their code end to end, and they have to understand and have a little understanding in infrastructure, security, reliability, all those things. So whenever something breaks, they also need to fix it. As long as they're busy fixing that issue, they're not developing new features, they're not writing new code, they're wasting their time on cleaning up the mess of the previous deployment. So this is one way where they stop, and the shorter the troubleshooting time is.
Like, I just wanted to know, are you sharing the screen?
Am I what? Sorry.
You're sharing the screen because I saw you talking.
Oh no, I'm not sharing yet. Not sharing yet. Just giving a quick answer, and then I'll jump to the. So like I said, the shorter the troubleshooting time for every incident, the faster they can go back to innovating, writing new code, and doing what they do best, which is building. So this is one aspect. Second aspect is the empowerment of developers that Commodore gives, because it's scary. I don't know if you've ever deployed to production and broke something. So it's scary because you don't know what will be the effect. So it kind of slows you down. With tools like Commodore, where you have the confidence that, okay, worst case, something breaks, I jump into Commodore, I quickly find out what was the case, why it broke, and how to fix it. So this gives me confidence to deploy more and be more, to be faster in what I do. So those are like the two parts where I think Commodore really, really increases the developer velocity, and which is an important part. I feel like with a lot of the customers we speak to, they are frustrated with the amount of time they spend on troubleshooting, the amount of time they have to spend on daily operations. Everything seems complicated with Kubernetes. And now, if you don't mind, I will share my screen and show everything. Can you see my screen?
Yes.
Okay, so welcome to Commodore. This is what it looks like. This is the very basic screen called the Service Explorer. So here you can see all of your microservices that are running within the cluster. And you can see straight away which ones are unhealthy or healthy. This is useful for a lot of developers that just care about their own service, their own app. So you can filter based on namespace, cluster. You can see just the unhealthy ones or just the healthy ones. If you can search for different namespaces if you like, to make it easier to navigate. And this is, by the way, something that we're working on at Commodore, and making everything I will show you just now more intuitive, faster. We added hotkeys and filters and search bars, everything just to make it as streamlined as possible and make you spend less time looking for things. So if you go into a specific service, you will get this timeline that I've mentioned, and you can see all the different changes that happen and the different events. You can go as far back as you want. And this is a really cool feature of Commodore, unlike other tools where you can only see a snapshot of what's going on right now. So you see my service is unhealthy, but what happened an hour ago or what happened a week ago, you don't know. So with Commodore you do, and you can see all the way back and draw conclusions from different events, deployments. And what's cooler than that is that you can also see the infrastructure level, and then you can correlate things. For example, if I see that I had a deployment here, straight after that deployment, I started having availability issues. And exactly around the same time, we're also having node issues. So I can clearly see that there's something going on here. So it's not just something on the app level, something is going on the infrastructure level. So when you click on the deployment, for example, so you can see when it started, when it ended, you can see the Kubernetes diff, see exactly what was changed. You can look at the code change on Git and add any useful links that may come in handy, like link to the direct link to the APM on Datadog, or you can see the build on Jenkins or any other tool that you're using. So this is part of the context that I was referring to. If you click on the node issue, then firstly you can see all those automatic checks that we ran. So we see that all the pods are healthy, the node is ready, but we do see that the node is under memory pressure, and we can see why. We can see that the low quality of service pods consume large amounts of memory, blah, blah, blah. And then you can see recommendations on what to do. And not only that, like I said, you can also see why we checked it. What did we check and why did we check it? So we have this thing for every Kubernetes resource, and you can also, if you're more of a visual guy like myself, so you can see this as a decision tree. Another cool thing that you can see is the best practices. I've also mentioned this, so you can see that we're missing a liveness probe. So this is a critical thing that we need to check ASAP. We can see that our memory limits are missing, but it's not a critical issue. However, the fact that the CPU request is missing is a bit of has a higher severity. Also, you can see the YAML directly here. So, like I said, this is for the preventive part, before something even breaks. The timeline is more of incident response thing, but it can also be used to just learn about different trends and events across your cluster. If you click on the availability issue, you can also get more information than what you would normally get using kubectl or K9s or any other CLI that is usually being used to troubleshoot Kubernetes. You can get the pod logs as well. This is also pretty cool because it means that everything is audited and you always know who touched the pod, who looked at it, who did what. And also it's giving the developers all the information they need without actually giving them kubectl access, which is better for your security and general reliability. Another thing you can see is the node status. So you can see what's going on with the node, and you can easily go up and down the stack. So if you're interested in like the specific deployment, because this what matters the most to you, you can go there. If you are an SRE or someone who needs a more higher level view, you can go and look at the nodes. And another cool thing, which is pretty new, is Commodore Actions. So now you don't just get the full picture, you don't just get all the context you need to troubleshoot. You can actually take actions directly from the platform. So you can basically do everything end to end within Commodore without having to jump off to other tools, CLIs, and platforms. You can basically do everything you want here. You can do a rollback. You can restart the service. You can even scale up or down. And you do that directly here with a click. So talking about making things simpler and easier to use for developers, this is exactly that. Another cool thing you can do is the events view. This is more of a higher level view of the system. It's multi-cloud, multi-cluster. So this is useful mainly for DevOps SREs who need to see bigger trends or events within the system. You can also see my manual action is already here. So it's, so we didn't miss anything. Even that manual deployment is, manual action of scaling up is audited and easy to find here in the events view. And you can see exceptions on Sentry, you can see jobs. You have a special view for jobs as well, where you can see jobs and cron jobs in a similar fashion to what you saw before. Same different timeline. You can even rerun a certain job. And monitors is a huge part of Commodore, and you have different monitors for different resources. You have for PVC, for cron jobs, whatever you choose, and you can configure them. You can choose to receive alerts in your preferred channel. You can set up thresholds, for example, PVC in pending state for more than 60 seconds. Maybe for you, 10 seconds is too much, so you want to make it lower. And you can configure any monitor you like for any Kubernetes resource, basically. And we offer the same monitors and playbooks we offer for any workload or Kubernetes resource, even CRDs. And so this is a very high-level overview of Commodore. And one last thing I'll show is this visual representation of the system. This can also be pretty cool and useful to educate developers and to give them a more visual view of the system that makes it more intuitive, easier to understand. This is just a cool new feature that our developers developed during a recent hackathon that we did. So this is basically it. Do you have any questions, Vishwas, or anything else you'd like me to show?
Yeah, that's it. That's it. I think probably you could have had demoed one thing more on using GitHubs or something, like anything gets pushed using GitHubs or something. Like I was expecting that, but yeah, like that's okay.
Oh,
if you have a demo, that would be good.
I don't have a
from Actions Marketplace. Like, is there a GitHub Action place that is like? Is there a GitHub Actions module written in the Action place for the Commodore? Like, I just wanted to.
No, not currently, but that's a good idea. Maybe it's something worth looking into, but currently no. You can do all those actions directly on Commodore. There's nothing in place with GitHub Actions at the moment, but I can recommend a really good tutorial from our last workshop with Alex Jones, where he shows how to integrate Commodore with GitOps type of workflow using Argo CD, Grafana, Prometheus, and Commodore. So this is a very good representation. And maybe in the future, Commodore will also cover the GitOps part, and we will be a real end-to-end solution where you can write your code, watch it, and troubleshoot it when needed, and everything's done end-to-end. Currently, we're just focusing on the operations part and the management, not just troubleshooting, but every operation for day-to-day ops and reliability maintenance for Kubernetes.
Sure. I think thank you so much, Yuri, for such kind of an insight with the demo. Means a lot. Thank you so much.